Alright, so factoring trinomials, which we first practiced in the last lesson, is a trying experience. We'll eventually get to see these applications for practical use, but for now we're going to get more practice factoring them. So look at the first one. I want to take out the greatest common factor first. So I need to see, is there something that goes into 4, 20, and 24? Well, 4 does, and I'm left with x squared plus 5x plus 6. Now we can use the technique where you decide what multiplies to equal the 6 and adds to equal 5. So we still have our 4, but now we can make a binomial. Multiplies to equal 6 and adds to equal 5 is 2 and 3, which are both positive. So this is your final answer, which is letter B. Apparently I worked ahead. Oops. So whenever we factor, we should always see if there's a greatest common factor first. So looking at the first one, letter A, there's a 5 that can go into all of those. So I have 2x squared plus 3x minus 2. We can use the AC method for this one. So we have our 5. We have our 2x squared. We have our negative 2. Now, A times C. So 2 times negative 2 is negative 4. Multiplies to equal negative 4, adds to equal 3. Well, that's a negative 1x and a positive 4x. That 4 is hard to see. And now we can make our 2 binomials. So we have our 5. Our greatest common factor for 2x squared minus 1x is an x, and we're left with 2x minus 1. Our greatest common factor for 4x and negative 2 is a positive 2, and we're left with 2x minus 1. So we have our 5. We have our first factor of 2x minus 1, and we have our leftover factor of x plus 2. Letter B, 3 goes into all of those, but so does an x. And we're left with x squared minus 7x plus 12. Multiplies equal 12, adds equal 7. Well, we have a 3x, and I know that I'm going to have an x and an x. Multiplies equal 12, adds to equal negative 7. Well, that's a negative 3 and a negative 4. 7 goes in all of these. We're left with x squared plus 3x minus 10. And multiplies equal 10, adds to equal 3. We have our 7. So multiplies equal negative 10, adds to equal 3. That's a negative 2 and a positive 5. And our last one, 2 goes in all of them. So 3x squared minus 1x minus 2. We have to use the AC method for this one. So 3x squared and negative 2 stay. Our A times C, 3 times negative 2 is negative 6. So multiplies equal negative 6, adds to equal negative 1. We'll have a negative 3 and a positive 2. Make our 2 binomials. And we have our 2. Greatest common factor between 3x squared and 3x is a 3x, and we're left with x minus 1. Greatest common factor between 2x and 2 is a 2, so we're left with x minus 1. So it's 2. Our first one is x minus 1, and our leftovers is 3x plus 2. To complete factoring, we can also involve factoring the difference of perfect squares. So let's look at letter A. A 2 can come out and we're left with x squared minus 9. We look at this. Is x squared a perfect square and is 9 a perfect square? Yes, they are. So I have 2, x and 3, x and 3. Since it is a conjugate, this is our final answer. We could take a 5x out, and we're left with x squared minus 4. X squared and 4 are both perfect squares. So our 5x comes out, and we have an x and a 2, because remember you square root both of them. You have plus and you have minus. Our next one, we can take a 3 out, and we're left with 4x squared minus 1. And again, both of those are perfect squares. So we have a 3, 2x, and 1, plus, minus. This next one, we can take something large out of both of those. So we have to find the greatest common factor between 54 and 24. Well, I know that 54 divided by 8, or sorry, not 8, 54 divided by 9, but 24 can't be divided by 9. I know that 54 can be divided by 3, and so can 24, but then I still have something larger. So 54 can be divided by 6, and so can 24. So a 6 comes out, and I'm left with 9x squared minus 4. Both 9x squared and 4 are perfect squares, so we have 6, 3x, and 2. If you understand factoring as breaking an expression into equivalent products, then essentially you can always check to see if you have factored correctly. So do the 3 terms of this trinomial have a greatest common factor other than 1? No. Why would the guesses 2x plus 2 and x plus 6 and 2x plus 4 and x plus 3 and 2x plus 12 and x plus 1 not make sense given your answer to A? Because all of those would say that a 2 could come out of them. So if a trinomial does not have a greatest common factor, then blank of its blank factors will have a greatest common factor. Well, neither of its binomial factors will have a greatest common factor. So we're going to factor this like we have before. So we have our A, we have our C, and our A times C is 24. Multiplies equal 24, adds equal 11. Well, 24, that's going to be 8 and 3, so I have a 3x and an 8x, and now we're going to do our binomials. Greatest common factor in the first one is x, and we're left with 2x plus 3. What? And in the next one is 4, and we're left with 2x plus 3. So 2x plus 3 is our first binomial, and our second binomial is x plus 4. And I want you to try factoring the last one on your own. So we have our A, we have our C, and our A times C. 4 times 18 is 72, but since 18 is negative, it's negative 72. So multiplies equal negative 72, adds to equal negative 21. Well, 72 divided by 2 is 26. 72 divided by 3 is 24. So it's going to be 3 and 24. 24 is negative, so it comes first. 3 comes second. Make our binomials 4x, and we have x minus 6, 3, and we have x minus 6. So our first one is x minus 6, and our second one is 4x plus 3.